pre-calculus students. We have another exciting trigonometry section for you today. Chapter 7.3, periodic graphs and amplitude. So let's start by talking about what kind of things we find in real life that can be modeled by a sine function, such as f of t equal 5 sine 3t plus 4, for example. Well, it can model things like length of day, voltage coming out of a socket, depth of water during the tide, sound waves, radiation, electrical engineering, and digital file compression. Basically, anything that follows a repeated cycle-like pattern could be modeled by a sine or cosine wave function. So those are the times where you're going to actually use this function, and let's look at, because it's going to be a function that repeats, it's going to have a period. So let's take a look at that. So we have the two basic sine and cosine functions, f of t equals a sine bt plus c plus d, or g of t equals a cosine bt plus c plus d. And these are going to be a sine and cosine wave functions, and a single wave is called a cycle. So the single wave of the graph is called the cycle, and the length of each cycle is called the period of the function. Basically, the period is going to be how long until the function repeats. So if we look at the sine graph, for example, okay, we can sketch this really quick. It goes from 0 to 2 pi with pi in the middle there, and then that's 3 pi over 2 and pi over 2, and it goes from 1 to -1. Okay, so that's the basic sine graph, and we're going to call this one sine cycle because that's one full wave before it repeats this pattern over and over and over again. So if we look at just the part of the graph that goes from 0 to 2 pi, that is going to be just one cycle. And so since it takes 2 pi worth of angle before, or 2 pi worth of time or angle before it repeats, then that's what the period is. So the period for the sine is 2 pi. Now let's look at the cosine graph. Similar thing. I've graphed actually graphed two cycles here, but if we just look at how long, if we just want to find one cycle, we need to go from peak to peak basically, and then it's going to repeat. So from where I highlighted in the yellow, that's going to be one full cosine cycle. And the question is, how long did that take? That will tell us the period. Well, it's the same as sine. It also takes 2 pi worth of time or 2 pi worth of angle to go through the function before it completes that cycle. Okay, so we've got the basic period for sine and cosine. It's 2 pi. And what happens when we multiply numbers on the inside? How does it impact the period? So let's look at this one. We have f of t. So a function with t as our input is equal to cosine of 4 times t on the inside. Okay, well, there's a couple ways you could look at this. One would be to just look at a graph and see how long it's going to take for it to repeat. So if normally it repeats after 2 pi, then if I just put in pi if I put in pi over 2 for t, it's going to be pi over 2 times 4, which is going to give me 2 pi, and cosine of 2 pi is 1. So we can sketch a couple of the points and look at the graph and see that it takes pi over 2 before this cosine repeats. Now there's an easier way to do it, which is to just look at the inside of the cosine function and say, well, we know cosine needs to see 2 pi before it repeats. So what t do you have to put in here so that it's equal to 2 pi? So we just set it up for t equals 2 pi, divide by 4, and we get that t is equal to pi over 2, which is going to be our period. So you can either do it by looking at the graph or just setting the inside equal to the basic period, which for cosine is 2 pi. Probably the second way is going to be easiest. That's what I would recommend. Okay, let's take a look at another one. Find the period of, this one's going to be sine of t over 2. Okay, so let's do the easier way where we just say, okay, this is supposed to be sine's eyeballs. Sine is checking out on the inside there, and it's saying, okay, when I see 2 pi, I'm going to repeat. So I just set t over 2 equal to 2 pi and solve for what t has to be. Just multiply 2 on each side, I get 4 pi. So the period's going to be 4 pi. Okay, and I'll just sketch one cycle of that. If the period is 4 pi, then it's going to repeat from 0 until 4 pi with 2 pi in the middle of the wave there. This is otherwise known as a horizontal stretch because it stretched the period from 2 pi to 4 pi. So that's also something to keep in mind. And the one thing you want to remember for doing these problems where you have to find the period because there's a number multiplied on the inside, so that changes the period of the function. It's in general, you can use the fact that if you have sine of some number b times t, or this works for cosine as well, cosine of b times t, well, all you have to do is you set b times t. Since the period is equal to 2 pi, in the basic sine and cosine, then you just set bt equal to 2 pi and solve for t, and you're going to see that the period is going to be just 2 pi over b. And that's a shortcut that you can use if you want. For me, I tend not to use the shortcut. I just kind of reason through it each time because I tend to forget the shortcut. But if you're someone that's good at remembering shortcuts, you can just, there it is. The period's going to be just the base period divided by the number that's multiplied. So if we have sine of 50t and we have to find the period, again, the way I think of this is, okay, sine with its little eyeballs is looking in there and saying, when I see 2 pi, I'm going to repeat. So then 50t equals 2 pi. What does t have to be? Just divide by 50 and we get 2 pi over 50, which reduces down to pi over 25. So again, the time before this sine function repeats is pi over 25. And that would be a horizontal compression because we went from a 2 pi period to a pi over 25 period. So we went to a lot smaller period. So that means that the sine wave is going to repeat much faster, which is going to compress the graph horizontally. Okay. Let's take a look at tangent. The one thing we have to remember about tangent is what is the base period of tangent? And stop and think about that. Yeah, it's not the same as sine and cosine, right? Sine and cosine both repeat after 2 pi, the base functions. But tangent, remember, the vertical asymptotes go from negative pi over 2 to pi over 2, and then they repeat every pi over pi. Oops, I drew that wrong. That should be 3 pi over 2 on that asymptote, not pi. But the tangent graph is going to repeat from asymptote to asymptote, and that's going to take pi worth of time to do. So the basic tangent period is pi. So we need to keep that in mind. Then if we want to find the period of tangent of 2t, we're going to say, well, tangent repeats after it sees pi, so what does t have to be for tangent to see pi? So we set 2t equal to pi, and we get that the period is going to be t equal to pi over 2. So in general, you can use the same shortcut as the sine and cosine. It's just that instead of taking the 2 pi divided by the number b that's multiplied, well, now you have to remember that tangent repeats after pi. So for the period of tangent, you got to take the base period, which is pi, and then you just divide it by the number that's multiplied on the inside times b. So that's the shortcut for tangent. All right, so that will solve any of your problems when finding the period with the tangent, cosine, or sine. Let's look at amplitude, which is the effect of multiplying a number in front of the sine, cosine, or tangent graph. Well, actually sine and cosine, because the amplitude of tangent is infinity, goes off to infinity. So the amplitude is the distance from the highest point to the middle of the wave. So in the normal base cosine sine, it's going to be 1 because that's the high point of sine and cosine and is 1 above the middle. So here, if we were going to look at this amplitude of this function, g of t equals 4 cosine 5t. First, let's get the period. The period is, when is cosine c 2 pi? So set the inside 5t equal to 2 pi, and divide by 5, the period is 2 pi over 5. So we can just draw our basic cosine wave and draw that the period is going to be 2 pi over 5, which puts pi over 5 in the middle. Okay, now the amplitude, one way to look at it is if we put in a few of these points, when t is 0, then 5 times 0 is 0, so cosine of 0, if we look at the unit circle, we know that cosine of 0 is 1, but then that times 4 makes the whole thing times 4. Now we put in pi over 5, we get 5 times pi over 5, which is pi, and cosine of pi on our unit circle, that's the point -1, 0, and the cosine is the x-coordinate, so it's -1, but then it's multiplied by 4 on the outside, so it's -4. So then I have the point pi over 5, -4. And then finally, I put in 2 pi over 5 times 5, 2 pi, cosine 2 pi, I'm at the point 1, 0, cosine's the x-coordinate, which is 1, so it's 1, but then times 4, so 4. So then the last point to look at is 2 pi over 5 is the input and 4 is the output. And the amplitude, again, is from the high point to the middle, so that times 4 on the outside changed our amplitude to 4. And in general, I'll summarize the effects of amplitude and period on the sine and cosine graphs. So in general, if we have the sine function f of t equals a times sine bt, t is our input here, and b is just some number multiplied on the inside, or the cosine graph g of t equals a some number times cosine of b, which is some number times t. Okay, so those graphs are going to have an amplitude of absolute value of a. So if it was multiplied by -4, then that would change the amplitude to 4. So you take the absolute value of the number. And the period is going to be the base period 2 pi over b. Thank you. See you in the next class.